Question number 10. Find a relation between x and y such that the point x, y is equidistant from the point 7, 1 and 3, 5. So as per the question, it is said that C is a middle point of AB, means C is equidistant from A and B. So as per the distance formula, we know BC. Clear? What is the distance formula of AC? How to find the AC? This is the formula we have. So equating both sides, we see that square root on both sides will be cancelled. Clear? And now for the value, x2 means consider that x2 is here, x minus y1 is 7 plus y2 minus y1 is 1 equals to, now this side BC mean B and C, consider this x2, x1 3, likewise y2 minus y1. Clear? Now we apply the algebra formula here, that is a minus b whole square. As per the rule, x minus 7 whole square, we get x square minus 2ab is equals to 14x plus 7 square is equals to 49. So also here y minus 1 whole square equals to y square minus 2y plus 1 square is equals to 1. Clear? So also here, so x minus 3 whole square equals to x square minus 2ab is equals to 6x here plus 3 square is equals to 9. So also here, so y minus 5 whole square is equals to y square minus 10x plus 25. Clear? Now if we compare or if you equate, there is a middle unequal. So what we see is the same thing, we can cancel it like x square cancel, again y square and y square cancel, we have again the remaining, they are supposed to be on y. So now we see what is left out, minus 14x plus 6x from right to left, bringing or transporting the negative become positive, minus 2y, again whereas we have the y here negative y, if we transport and bring it become positive 10y equals to, now without the variable, like here it is without the variable, here also we have the without variable, here also without variable, here also without variable, I mean they are the constant. We put all the constant numbers on the right, like minus 49, and here minus 1, and here plus 9, and plus 25. On solving this we get minus 14x plus 6x, we get 8x minus 8x, and here minus 2y plus 10y equals to plus 8y. And what about this side? Minus 49 minus 1 minus 50, minus 50 plus 9, we get it minus 41, and minus 41 and 25, minus 41 and plus 25, we get it 6, then here 1, minus 16. So all the number whatever we see is divisible by 8, so come with 8, dividing with negative 8, 8, here minus 1, here 2, here x, then minus y, minus, not minus, only 2. Clear? So where is our answer matching? Our answer matches with option A. So this is our answer. Our correct answer comes option A. So option A is the correct answer. Question number 12. So number A, tan 90 minus A. Number B, cosec 31 degree minus sec 59 degree. Number C, tan 65 by cot 25. Number D, cos 30 degree. And on the right side we have Roman 1, root 3 by 2, Roman 2, 1, Roman 3, cot A, Roman 4, 0. These are our final option. Clear? This is the answer. We have to adjust here. So what we must do? It is not necessary that we solve it line by line. It is not necessary that we must know all the answer. Clear? One or two knowing that is sufficient in matching the choices. Like tan 90 minus A is equals to cot A, where we have like 1 is matching with Roman 3. Clear? So where we have A is Roman 3, A is Roman 3, A is Roman 3. This is already cancelled. This also already cancelled. Clear? Why? Because here A is equals to, or A is matching with 2. Here also A is matching with 2. That's why you cancel. No need to say again other. Only our option will be out of this 2. That is either A or B. Clear? Now the other one we know. You leave with this. Now comes here cos 30 degree. Cos 30 degree. What is the value of cos 30 degree? That is root 3 by 2. But it matches here. That is D is matching with Roman 1. So out of these two, D is matching with Roman 1. So here D is matching. That is our answer is option A is the correct answer. Clear? I hope you understood this. The others are not necessary to solve. Question number 13. Here we have, if the point A 2, 3, B 4, K and C 6, minus 3 are collinear, then the value of K is. Here are the options. So we know, as per the distance formula, if it is collinear, then we have area of triangle equals to 0. Clear? So before that we have to take here x1, y1, x2, y2, x3, y3. We have 1 by 2 x1, y2 minus y3 plus x2, y3 minus y1 plus x3, y1 minus y2 equal to 0. Area of triangle formula we have here, then equals to 0. So now on placing the values, 1 by 2, x1 is 2, then y2 we have 4, not 4, sorry, k minus and minus 3, k minus and minus 3 plus y2, sorry, x2 4, then y3 minus 3 minus 3, minus 3 in the rule minus, again y1 is 3 plus x3 we have 6 and y1 3 and y2 k, 3 minus k equals to 0. Clear? Now we transport this, only we have here 2 k plus 3 plus 4 minus 6 plus 6, 3 minus k equals to 0. Now we write 2 by 1. On solving this we get 2k plus 6, 6 4s are minus 24. We clean here. So plus 6 3s are 18 minus 6k equals to 0. Now we solve the like term, that is the variable 6k minus 6k and plus 2k, and the constant term we solve it separately. Likewise 2k minus 6k equals to minus 4k, and we get here 6 minus 24 minus 18, minus 18 plus 18 we get it 0. Clear? All this cut off, then we have finally 0. So the value of k is 0 divided by minus 4 is equal to 0. So what is the value of k? The value of k is 0. Then which is the correct answer? The correct answer is option C. Question number 14. Here we have assertion and reason. Assertion. A pair of linear equations in two variables has a unique solution. Reason. Two distinct lines drawn on a plane will either be parallel or have a point in common. Here are the options. Option A. Both A and B are true and R is the correct explanation of A. Option B. Both A and B are true and R is not a correct explanation of A. And option C. A is true but R is false. Option D. A is false but R is true. So we have to see the assertion is true or false first. If assertion is false, then we have only one option. If assertion is true, then we have three options. Clear? Either A, either B or C. Now let's see assertion. A pair of linear equations in two variables has a unique solution. Is it true? Yeah, can be true. Yes or no? But it is not the only option we have. A pair of linear equations in two variables can be a unique solution, can be many solutions, or can be parallel. Yes or no? We have three options. So it is not only a single solution that is unique solution. Yes or no? We have other than the unique solution, we have two more solutions. So we cannot say that it is a only solution. We can say true, but that is not a final solution. It can be a parallel. It can have a many solution, more than one solution. So our assertion is not a correct answer. So as for this, since assertion is false, we can say option D is our correct answer. Here we have a formula to have a glance. Question number 15. Here we have assertion. Point P 4, 2 is equidistant from Q -1, -1 and R 1, 7. And reason we have P is the midpoint of the line segment QR. And here are the options. Out of these four, one is correct answer. So let's see. Equidistant, but we will not follow the distance formula. We will use it here, midpoint theorem. As per the midpoint theorem, we will name Q as x1, y1 and R x2, y2. X1 and y1, here are the values x2 and y2 also. So placing the values of x1, y1, x2, y2, we have x1 -1, x2 1, and here so 0, 3 is the correct answer. So which is not matching here. So our option is the D, where we have only assertion false. So our option number D is correct answer. Option D is the correct answer. Clear? Why? Because there is only one option whose assertion is false written here. Clear? Question number 16. Assertion. 2x minus 1 whole square minus 4x square plus 5 equals 0 is not a quadratic equation. Reason: x equals to 0, 3 are the roots of the equation 2x square minus 6x equal to 0. Now let's see. Assertion and the reasons are true or false. Clear? First of all, we have So 2x minus 1 whole square mean a minus b whole square formula. Let's apply it. What is the formula? A square minus 2ab plus b square. So here applying the formula we get 4x square minus 4x plus 1. Then remaining then we get here 4x square positive and negative 4x square cancel. Here we have minus 4x 1 plus 5 plus 6 equal to 0. So we get here power is x power, you will see it is only 1. It is a linear, not a quadratic. Here said not a quadratic. Yes, it is not a quadratic. Clear? It is a linear. It's a linear equation, not a quadratic. Therefore, it is true. Assertion is true. Assertion is true we get. Now second we have 2x square minus 6x equal to 0. We can add the common. Like here we have 2x common. An uncommon one, x minus 3 equal to 0. Now either 2x equal to 0, x equal to 0 by 2, x equal to 0, or x minus 3 equal to 0, x equals to 3. So our reason also is correct. Here also correct. That means either A or B is our correct option. But here we see reason is not related to assertion. Here separate quadratic equation. We are finding the reason of roots in reason. So both are not connected. Means the reason is not from the assertion. Therefore, our correct answer is option B, where both A and B are true and R is not a correct explanation of A. Clear? Therefore, our answer is option B. Question number 70. Given that sin theta equals to A by B, find cos theta. We are going to use here right angle triangle. That is by using Pythagoras theorem. Clear? We know sin theta equals, sin theta is given here equals to, so by Pythagoras theorem we have hypotenuse square, p square, perpendicular square, base square. Clear? And we need base. So hypotenuse square minus p square equals to base square. So h square minus p square, the square you bring this side, square root b. Clear? Base we have root over, inside the root over, hypotenuse square minus perpendicular square. So now we need cos theta. Cos theta base by hypotenuse. What is the base we have? The base just now we got it. Root over hypotenuse square minus perpendicular square by hypotenuse. Now on placing hypotenuse and perpendicular, we get hypotenuse we have here hypotenuse b square minus perpendicular we have a square by hypotenuse we have b. So that is our answer. Clear? Taking the value of h equals to b and p equals to a, we get square root b square minus a square inside the root over by b. So which is the correct option? Our correct option is C. Clear? There is another rule you can see. Here we have sin theta equals to a by b. Here I wrote. Clear? Sin theta equals to a by b. Now squaring both sides. Squaring on both sides. Then in place of sin theta we can write it since sin square theta equals to 1 minus cos square theta. Clear? So we write here in place of sin theta 1 minus cos square theta equals to a square minus b square. Clear? Now just you transport cos theta from left to right, and a square by b square you transport left side. See, a square by b square become negative, the positive becomes negative, and the cos square theta, it was negative, becomes positive when we carry or transport from left to right or left to right to left. Clear? Now doing the LCM. B square minus a square by b square equals to cos square theta. Square it on both sides. Here we can cancel, but here b square minus a square inside the root over by here root will get over is equals to cos theta. So this is the second method here we can apply. So our correct answer is option C. Question number 18, we have the product of the LCM and the HCF of two numbers is 24 and the difference of two numbers is 2. Find the numbers. Numbers we don't know. So here is very easy, we don't need to go through the question, we can go from the option also. Like a difference in minus of two numbers must get 2. Now let us suppose this statement, difference in minus of two numbers. So here are every option up to 2 number we have. So let's do here 8 minus 6 we get it 2, that is also correct. And 10 minus 8 here also we get it 2. 6 minus 4 here also 2 we get. So minus 6 minus 4 we get negative 2, that is not a correct answer. Clear? So out of it is 3, we get it, the difference equals to 2. But here say product of LCM and HCF is 24. So let's break it. Product means into of LCM. LCM into HCF equals to 24 must get. Clear? Now let's see option number A. Option number A, the common 6 is equals to 2 into 3 and 8 is equals to 2 into 4. 6 equals to 2 into 3 and 8 equals to 2 into 4. So 2 is common, HCF and LCM, the common number is 2, then 3 into 4 equals to 24. Now on placing the value of LCM and HCF in here, LCM we have 24, HCF we have 2, we get it 48. So that is not a correct answer, I mean this is not a correct option. Now let's see option number C. So your common number we have 2, that is our HCF and LCM, common number 2 and the remaining number 2 into 3, 12. On placing the values of LCM and HCF, we get it LCM 12 into 2 equals to 24. So which is matching, means our correct answer or option is option C is the correct answer. Question number 19, here we have, if P and Q are the zeros of the polynomial fx equals to 2x squared minus 7x plus 3, then find the value of P squared plus Q squared. We know P and Q are the zeros. Clear? So let's do sum of zeros, P plus Q equals to, we have minus B by A. What is the B we have? That is minus 7. Minus and minus 7. And A we have 2. A is 2. Clear? On solving we get 7 by 2. Now again, what we need? Product P into Q, C by A, C by A. What is C? Positive 3, that is C by A. A is 2. So now, and P plus Q whole square, squaring both sides from this part, clear? Squaring on both sides, we get P square plus Q square plus 2PQ equals to 7 7 are 49 by 4. Applying the algebra formula A plus B whole square, we get P square plus Q square plus 2PQ equals to 7 by 2 whole square, 49 by 4. Here we have P square plus Q square plus 2, and PQ value we have here 3 by 2 equals to 49 by 4. Now we solve here 2 we cancel it, only we are left with positive 3. P square plus Q square, we transport this positive 3 from left to right. So now we do the LCM on the right. 4 3s are 12 by 4 equals to 49 minus 12, we got it 37. So which is the correct option? Our correct answer is 37 by 4. So our correct option is option C. Clear? It is very simple. Only you must know the sum and the product rule. Clear? Question number 20. Here we comes. Which of the following is not a quadratic equation? So remember, not a quadratic equation. Not a quadratic equation. So option A, B, C, D are here. We have to find out. We have to solve it. But all A, B, C, D is not necessary. First, understand here, not a quadratic equation means the given equation we should not have the highest degree or highest power as 2. Clear? It must be other than 2, or there should not be any square. The degree should not be 2. The highest degree should not be 2. So let's see in which option it's possible that we check first. Like first I see here, if you see all the 4 options, option C, let's see first. Applying the formula A minus B whole square, we get so applying the formula A minus B whole square, we get root 2x whole square minus 2 root 2x root 3 plus root 3 whole square plus x square equals to 3x square on the right. As it is, I wrote minus 5x. Here root and square cancel, but for x square is remaining. Here we get 2x square, and here we get 2 root 6x, and your square root and square cancel, only 3 remaining. X square as it is, on the right as it is. Square 2x square and x square, on solving we get it 3x square. Clear? X square and 2x square, on solving we get 3x square minus 2 root 6x plus 3 equals to 3x square minus 5x. So there is an equal symbol. We see which number we can equate, mean we can remove it. Like a 3x square, 3x square. No more, the highest degree as 2. So it is not a quadratic equation. Clear? All the other 4 options, C option is not a quadratic equation. Why? There is no more square. It means it is a all linear equation. There is power as 1. There is x. It is an equation, but it is a linear equation, not a quadratic equation. Clear? Therefore, here since the question asks not a quadratic equation, our correct option is option C only.